AI Podcast. I'm David. Today we're turning a recent arXiv review into a clear conversation. The title is AI Agents versus Agentic AI, a Conceptual Taxonomy, Applications, and Challenges. The short version is this. Single agents are great for bounded tasks, and Agentic AI means a coordinated team of agents with memory and orchestration to pursue broader goals.
Hi, I'm Maya. So, conclusion first. Use a solo agent for contained chores, and reach for an agentic setup when the work has many moving parts. Makes sense.
Right. The paper is led by Ranjan Sapkota at Cornell University, with colleagues Konstantinos Roumeliotis at the University of the Peloponnese and Manoj Karkee at Cornell. It's a literature-based review, revised in late May 2025, and the goal is to give builders a shared vocabulary.
Before we dive in, can we set the stage? Why draw such a firm line between agents and agentic AI?
Because the word agent has been used for everything from chat assistants to teams of autonomous bots. That blurs expectations. The authors argue we should name the difference. An AI agent is typically one model using tools and some reasoning to finish a specific task. Agentic AI is a coordinated ensemble where multiple specialized agents communicate, plan, remember, and divide work under an orchestrator.
So the risk is building the wrong thing, either over-engineering a simple job or under-scoping a complex one.
Exactly. They review earlier lines of work like expert systems and multi-agent systems. Those gave us a foundation, but they lack today's learning-driven adaptivity. Modern language and vision language models unlock that power, along with new weaknesses like hallucination and shaky causal reasoning.
Which brings us to gaps in prior methods. What did they find lacking?
For single agents, 3 recurring issues: hallucinations under pressure, brittle prompt chains, and week-long horizon planning. For multi-agent setups, the problems compound. Errors can cascade across agents, coordination can stall, and outcomes can be hard to explain. The authors also call out a culture gap, shiny demos, and thin evaluation.
Yeah, I've seen that. Add one more step and the demo wobbles.
To restore clarity, they propose a taxonomy with 5 lenses: architecture, mechanisms, scope and complexity, interaction, and autonomy. Those lenses help match the problem to the design.
Walk me through them in plain language.
Architecture asks what sits where from a single model with tools to a multi-agent system with an orchestrator and shared memory. Mechanisms are how it works, from prompt reactive loops to inter-agent messaging and task decomposition. Scope and complexity cover the size and variability of the job. Interaction is how much the system needs to talk to users or other agents. And autonomy is how far it can go without constant nudging.
So for an engineer, those lenses tell me when I need a team rather than a soloist.
That's it. Method-wise, this is a structured review, not a controlled experiment. They searched across major academic databases and used AI discovery tools, described their queries, and then synthesized patterns into comparisons, figures, and tables. Think of it as a map.
Helpful expectation setting. What examples ground the map?
For single-agent loops, they mention AutoGPT and Baby AGI, which wire a language model into a plan-act-reflex cycle. For agentic orchestration, they point to frameworks like CrewAI and graph-style controllers that route tasks among specialists. The paper also notes Google's agent-to-agent protocol, often called A2A, introduced in 2025 to standardize how agents talk across frameworks.
So 2 trends at once, better solo loops and better plumbing for teams?
Exactly. On applications, solo agents shine in focused tasks like support, internal search, email triage, and routine scheduling. Agentic AI makes sense when goals are broader and evolving, like multi-agent research assistance, collaborative medical decision support, logistics and robotics coordination, and adaptive workflow automation.
And how do the authors interpret all of this?
They're careful. Tool-using agents move us from passive generation to reliable task execution. Agentic AI extends that to coordinated goal pursuit under uncertainty. To make that jump work, they emphasize 4 ingredients: orchestration for clean handoffs, persistent memory for context, stronger reasoning with causal grounding, and serious evaluation so we can measure coordination quality and safety.
Without evaluation, you can't compare two teams that look similar on a demo.
Right. They also discuss a forward-looking idea called absolute zero, or AZR. The idea is self-play reasoning with zero external data, where systems propose tasks, verify them with tools like code execution, and improve through self-play. Interesting, but early.
I can hear safety reviewers leaning in on that one.
The authors treat it as a direction, not a done deal. On the critical side, they acknowledge that the review isn't a protocolized systematic study, so completeness is hard to judge. Definitions can blur in real systems, and reproducibility is a problem without shared benchmarks and auditable traces of orchestration, memory updates, and tool calls.
So the main cautions are selection bias, fuzzy boundaries, shaky apples-to-apples tests, and safety when systems start teaching themselves.
That's a fair read. Practical takeaways for builders. First, classify your problems using the 5 lenses. If the scope is narrow and the interaction surface is simple, stick to a single agent with retrieval, tool use, and a tight feedback loop. If the task has several roles and many handoffs, design for orchestration and shared memory from the start. Instrument everything so you can debug coordination, and pick an interoperability story early.
And for researchers,
3 threads stand out. Build multi-agent benchmarks that stress causality and error cascades. Explore memory architectures that mix episodic, semantic, and shared team memory with clear retention policies. And evaluate emerging protocols like agent-to-agent in real deployments, not just toy examples.
where would you try that AZR idea first?
In bounded settings, code execution sandboxes, theorem proving, controlled simulations, look for measurable self-improvement with verifiable rewards and strong guardrails. If it works and stays safe, expand. If it misbehaves, use the logs to diagnose and dial it back.
Nice, clear labels, clear risks, and actionable steps. Thanks, David.
Thank you, Maya. That's our look at AI agents versus agentic AI. If you found this useful, follow AI Podcast and send us the next paper you'd like unpacked.